So we saw that hmm, sum of two rational number is a rational number, and therefore we can say that rational numbers are closed under addition. Okay, closed under addition. This is known as closure property. Closure property means when you do addition operation on a rational number or any type of number, if you get rational number, okay, then you say that rational number is closed for addition. But means LHS side and RHS side you get the same type of rational number. Okay, so we can analyze closure property for other numbers also, like for natural numbers or for integers. Okay, this we have seen for natural rational numbers. We will see for integers and natural numbers later. Now next we have to see that will difference of two rational number will be a rational number, that is will or is a rational number is closed under subtraction. Okay, so here in example minus 5 by 7 minus 2 by 3. Okay, we got minus 29 by 21. This one is LCM of 7 and 3, and 5 into 3 minus 2 into 3 7 ja 21 to 2 7 29 by 21. Okay, it's also a rational number, minus 29 by 21. Why? Because it can be written in the form of P by Q, where Q is not equal to 0. Q is not equal to 0. So it is also a rational number. For let's practice for some other examples also. Minus, sorry, 5 by 8 minus 4 by 5. We got how much? 25 minus 32 is minus 7 by 40. Okay. Now let's move to other example. For let's see what in the case of product in multiplication. Okay. No, let's come back. So we saw two examples. Now we can say that for we find that rational numbers are closed under subtraction. Okay, means what it means that when we subtract two rational numbers, we will always get rational number. That is for any two rational numbers a and b, a minus b is also a rational number. Now we will check whether rational number is closed or whether rational number is following the closure property in case of products or multiplication. So here in first example, minus 2 by 3 into 4 by 5, what we get? Minus 8 by 15. So it is also a rational number in the form of P by Q, where Q is not equal to 0. 3 by 7, A into B, 2 by 5, we get 6 by 35, C. That is also a number, rational number. So A, B, and C both are going to be rational number. LHS rational, we use rationals in LHS. We got rationals in RHS. We got rationals in RHS. So we can say rational number is closed for multiplication. Both products are rational numbers. Now you try to solve this equation. Minus 4 by 5 into minus 6 by 11. What will you get? Minus minus will cut out. So we'll get positive 24 by 55. So it is also a rational number. Take some more pair of rational number and check that their product is again a rational numbers. Okay. For example, I am giving you example. 1 by 2 into 3 by 5. Will it be a rational number? Solve for yourself. Yes, it will also be a rational number. You will get 3 by 10. It is also in the form of P by Q. We say that rational numbers are closed under multiplication. These are closed under multiplication. That is for any two rational numbers A and B. A into B is also a rational number. Okay. So examples. Now let's take another check that whether rational number is closed for division operation. Okay. So minus 5 by 3 divided by 2 by 5. What we will get if you try to solve this equation? We will this will division will get into and this will change. The denominator will shift to numerator and numerator to denominator. So we will get minus 25 by 6. So it is also rational numbers. 2 by 7 divided by 5 by 3. What will be answer? 2 by 7 into 3 by 5. That is 6 by 35. So it is also a rational number because it can be written in the form of P by Q where Q is not equal to 0. Now solve for this. Minus 3 by 8 divided by 2 by 9. So minus 9 by 2. What we will get? 27 by 16. Minus minus will cut out to 27 by 16 is also a rational number. Can you say that rational number are closed under division? So it seems that rational number is closed under division. But wait. What for 0? What for in the case of 0? Because in the very definition of rational number, we have what we said that numbers in the form of P by Q where Q is not equal to 0. Okay, but we are checking closure property of rational number for division. 0 is, if we take individually 0, it is also a rational number. It can be written in the form of 0 by 1. But 0 can't be in denominator. So we can say if if P is a rational number, it can be divided by any rational number except 0. So the closure property will follow for all other rational numbers except 0 as a denominator. So rational numbers are not closed under division. However, if we exclude 0, then the collection of all rational number is closed under division. So you can say it is almost closed under division. Okay. So except 0. If you remove 0, the rational number is closed under division. 0 should not be present as denominator. Next. Ah, so there is a small exercise for you. Fill in the blanks in following table. Numbers, raster numbers. Is it closed for? We have to analyze for closure property. Okay, we have to analyze for closure property. Is it raster number closed under addition? Yes, we saw. Is raster number closed under multiplication? Yes, we saw. Is raster number closed under multiplication? Yes. Is for division? No. Exception 0. In case of 0, it fails. Okay, anything divided by 0 is not defined. Now, it is also asking for addition for integers, whole number, and natural number. Where integer is closed for addition? Yes. Actually, we have left this part. Let's move back and we should analyze this also. Here, once we solve this table, we will fill that table. So, closure property analysis on whole number. Let us revisit closure property for all operation on whole number in brief. Okay. So addition. We are adding two whole number. 0 is also a whole number. We are adding 5. We get 5. 4 plus 7. We get 11. Whole number, both sides. In general, a plus b is a whole number. For any two whole number, a and b, the whole number. Okay. We get a plus b as a whole number. So whole number is closed under addition. Okay. Closure property follows under addition. Now for subtraction. 5 minus 7 is minus 2. Minus 2 is not a whole number. What are whole number? 0 plus natural numbers, counting numbers. Okay. 1, 2, 3. 0 plus natural number is a whole number. Whole number is not closed under subtraction because when we are subtracting two whole numbers, okay, we are subtracting two whole numbers, we are getting integers. Multiplication. In case of multiplication, we are multiplying whole number, we get 0. 0 into 3 is 0. Whole number into whole number is a whole number. So we can say whole number is closed under multiplication. In general, if A and B are any two whole number, their product AB is also a whole number. Next for division. Let's check for division. We are dividing two whole number 5 and 8. We get 5 by 8, which is not a whole number. This is a We have just learned it is in the form of p by q, so it will be rational number, form of ratio. Whole number is not closed under division. So what we found, whole number is closed for addition, whole number is not closed for subtraction, whole number is closed under multiplication, and whole number is not closed under division. Next one is we will see closure property on the type of number, that is integers. So first, what are integers? Please try to recall. First, we get natural number that are 1, 2, 3, 4. Okay, naturally occurring. When we added 0 to it, it become whole number. And when we went to its negative side also, minus 1, minus 2, minus 3, okay, then the complete set is going to be called as integers. So now we will check properties, closure property on various mathematics operation in case of integers. Addition. We are adding two integers, minus 7 plus 5. We get minus 1. Minus 1 is also integer. We are adding two integers, minus 7 plus minus 5. We will get minus 12. It is also an integer. 8 plus 5. It is 13. It is also an integer. Okay, in general, a plus b is an integer for any two integers, a and b. That is, integers are closed under addition. Closure property is being followed. In case of subtraction, 7 minus 5 is 2, is an integer. 5 minus 7, but we will get minus 2. It is also an integer. Minus 6 minus 18, minus 8 minus 14. It is also an integer. So we can see that integer is closed under subtraction. Closure property is being followed. 6 minus minus 8, we get 2. 8 minus minus 6, it is an integer. So in general, for any two integers a and b, a minus b is again an integer. Check if b minus a is also an integer. Yes, we had just checked. Let's move with new example. 5 minus 7 is integer, that is minus 2. 7 minus 5 is an integer, 2. Okay. In case of now we move to other next check operation of multiplication. We are multiplying two integers. We are getting integers. Minus 5 into 8 is also an integer, that is minus 40. Minus 5 minus 8. will be 40. Product will be 40. Minus minus will cut off. So for A and B and an integer, we get product A in B. A into B is also an integers. Let's check our example with 0. For example, we are taking 0 into 8. We get 0. So 0 is also an integer. It is coming in integer set. For division, let's check for division. 8, 5 by 8. 5 by 8. Is it an integer? No. It is in the form of P by Q. That's a number form. So it is not closed for division. That if we have A and B as integers, uh, it is not sure that we will get AB as an integer. Okay, for example, this example. Uh, or we take another example, 2 as one integer, 1 as other integer. We will divide 2 by 1. So in this case, it is following. But in the example we saw, it is not following. So it should follow in all the cases. Then only we can say confidently that it is following that property. We can say that this is its property. You have seen that whole number are closed under addition, multiplication, but not subtraction and division. However, integers are closed under addition, subtraction, multiplication, but not under division. So, whole number were closed under addition, multiplication, but not under subtraction and division. But integers were closed under addition, subtraction, multiplication, but not under division. Okay. Uh, we have seen this one. Now we will be able to fill this column. So integers, was it closed under addition? Yes. Closed under subtraction? Yes. Closed under multiplication? Yes. Whole number. Closed under addition? Yes. Closed under subtraction? No. Because we will get getting minus sign also. Closed under division? No. We divided two whole number. Mostly we were getting rational numbers. Natural numbers closed under addition? Yes. Closed under subtraction? No. We can get integers. Closed under multiplication? Yes. Closed under division? No. We will get rational numbers. So we can say we see none of these number is closed under division, multiplication. Everyone is closed under multiplication and everyone is closed under addition. For subtraction. These two. Whole number and integers are closed. These are not closed. Okay.